Yeah,
all right.
Million
Yes. All right, this video is going to go
viral.
diamond. All right, Mr. G, Beast.
Get out.
All right.
Out.
Students who complete this assignment get $1 billion. But now, let's do this warm-up. Did you know, or do you know, what this 1/2 does to the graph? It's less than 1, so it's a vertical what? Compression. Why is it compression? Less than 1. Bigger than 1? Bigger, think of stretch. But compression, think of like your accordion. Okay, so vertical compression. Now, the next thing, I see this +7. It's on the inside, so it's a what? Because it's an insider, and insiders lie. Remember, insiders are like, it's your X, it's horizontal, and it's a lie. Okay, so left 7 was correct. And then what does this -5 do? Down 5 because it's vertical and it's no lie. So the cubed is part of the function. That's not a transformation. All cubic functions will have that cubed, but the things that'll change are the a out front, the h on the inside, and the k afterwards. So the cubed is just leave it alone. You're good. Yeah, that is the ideal answer. Because you're identifying what the function is, and you're telling me all the transformations. So good on you. Very good. All right, so let me pass this out. We got to do 7.2 notes because now we're extra behind because I wasn't feeling well Monday. Did y'all enjoy your random weekend in the middle of the week?
I did. I wish it was for the rest of the week.
Did anybody do anything interesting? Did you get a snowman with all the snow?
There was snow?
No, that's a joke. There was no snow. Did you slip on the ice?
I pushed my brother on the ice, and that was bad. No. I stood inside. I pushed my brother outside. He took $40 out of my wallet, so it was payback.
All right.
It was funny seeing him fall.
Hey, but we should do something fun on Monday. What should we do? What should we do?
We should watch a movie.
Costume party?
Hell no.
Yeah.
Oh.
It'd give me
Hell no.
wear something weird.
Well, as long as you can.
That's true. That's what they call it.
Hey, Monday, dress like Mr. G Day.
Hell no.
I don't know what that is,
I'd
but
rather be a dinosaur.
I'd love to see it. All right. Well, here we go.
Wear a onesie on Monday.
Now, you're not saying that's what I would wear.
You watch him wear a Cowboys onesie just like this.
That?
Even though his team's out of the Super Bowl.
That would. Look.
I'll wear my Tennessee shirt.
Oh, yeah. We'll wear something related to Chiefs.
Now, do you know where the Chiefs were from?
I don't know.
The Kansas City Chiefs moved from Dallas, Texas. They were the Dallas Texans. So I can still root for Dallas in the Super Bowl. It's just not the Cowboys. All right, anyways.
I think my home's gonna win.
You better, because the Eagles cannot win.
Watch the Eagles. If we say the Eagles win and they win,
I would
that's
be.
gonna be funny.
I'll be sad.
I need to create a football team and put it in there just to start messing with you guys.
No missing. All right.
I don't even watch football, and we just talk about it all the time.
We call it Irish.
All right, here we go. Let's start. 7.2 notes. By the way, from Monday when I was not feeling too well, I have a sore throat. I do not want to yell or raise my voice too much. So hopefully you can hear me. Let's do this. So you're going to be able to do these two objectives, as you can see here. We're going to try to determine the end behavior of functions, and then we're probably going to just do that. TBH. I know. So I will tell you that we're not going to do the second page today, so we'll just, I promise you, it's not that bad. It's actually the worst thing ever. Yes. All right, so let's go to definitions. A degree, or the degree, refers to the highest exponent used in a polynomial function. So whatever the biggest exponent number is, that's your degree, okay? Now, is everyone looking up here, not at your phone or something else, or, okay. Now, then the second thing you need to know is the number of quote-unquote bends, okay? So when you see a graph doing something like this, okay, whenever it changes directions, that's a bend, okay? However many bends there are can help us understand something about these polynomials, okay? So a bend is when the graph changes from increasing to decreasing and decreasing to increasing. And then we have the end behavior. So here's what I mean. Look at my hands. Let's pretend like my hands are graphs, right? So a graph can start up and end up. Touchdown, okay? Sometimes it can start down and end down. Sometimes it can start up and down. Sometimes it can start down and end up, okay? So there's all these different possibilities of what it could be, right? Yes. Now, that's called end behavior. Whatever happens at the very end is the behavior. It's either positive or negative. Positive or negative. Now, let's look at this example. Ready? Is everyone looking? It's on your page, but it's up here too. If you were to graph this in your calculator, okay, you could get the graph. Can we erase or no? Apparently we can't erase. Hold on one second. There's something goofy here. Wait. So if you take this and you graph it, you're going to end up with this graph over here, okay? But the first question it's going to ask you is degree. So what's the biggest exponent you see right there? 2. So don't you agree that that is pretty easy to tell the degree, right? Right? Okay, so everyone can tell what the degree is. It's the biggest exponent. Now, second thing, sketching it. You don't have to make a perfect sketch, but you need to make a nice representation. So how would you have done that? You would have gone into your calculator. You would have pressed new document, don't save, number 2, negative 10x squared plus 63x minus 80. Okay. Now, here's what I want you to notice. When you graph these, it's going to be hard to see it unless you can expand it out, okay? Have y'all ever messed with the zoom of a graph?
No.
Okay, so we're going to learn some buttons. Ready? Press menu. Is everyone listening and looking? You got to look up here. Menu. Now, which one says window? Or zoom? 4. Number 4, window zoom.
Oh.
Okay, so you press menu 4. Now here's all your options. There's only one number to remember. No, actually, you could do menu 4A, zoom fit. Let's try zoom fit. Look at that big old looking menu 4A. So zoom fit, let's go and write this down at the top. Zoom fit is menu 4A, okay? So if it's ever like, I can't really see this graph, menu 4A will fit it to where you can see most of it. Now I'm going to tell you ahead of time, sometimes when you do menu 4A, it's too much. Like you zoom out too much and you can't see all the little details. I'll talk about that in a minute, okay? But for now, do you agree that that shape is what is sketched right there? Right? Now, how many bends are in that graph? So look, it's going up, 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 and it stops right here, and then it goes down, down, down. So it has one bend. Does that make sense? One change of direction. Oh, there's one bend, one change in direction, right? Is everyone with me? So here's the question. Next question. What's the end behavior on the left? So
Right.
on the left, is it going up or down? Which way is that going? Yeah, on the left, is that going up or down? Down. So that's why this is circled, okay? And on the right, which way is that going? Down. Okay? So I know that one was already done, but I want you to see how they got these numbers. So let's do number 2. Okay? Can we graph this in our calculator? Yes! Let's do it. So now, by the way, y'all know how to edit your graph. I can press tab. I can go up and just start editing what I had there before. All right, so I'm going to type in 8x squared minus 55x minus 61. I hit enter. Now, I can see it, but what would I press to fit it? Menu what? 4A. Now I can definitely see that. So you see how it's like a U shape? It's a parabola. By the way, what's the degree? What's the highest exponent you see there? 2. Now, can we sketch a graph of this? Go ahead and do that. Look how horrible my graph is. So try that again. Should just be a U. Right? Now, how many bends do you see? It's going down, 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 and it stops. It goes up, up, up. How many bends is that? One bend. It goes down, then it goes up. That's one bend, one turn. Okay. Now, what is the end behavior on the left side? Which way is this going? Up. You'll see that on the left? Up, up, up. Circle that. On the right side, which way is that going? Up, up, up. So that's... Okay, now we're going to use all this information to make some conclusions. Okay. Number 2 here. Okay. Now, what is the degree? It's not 97. Because no. So no. It's not even 0. Check it out. The degree is the biggest exponent you see. Now, listen, 182 has no x, so forget it. The only x, oh my gosh, get out of here. The only x I see is right here. The question is, what number is, if there's, okay, so if there's no number, how many x is that? Well, there's, okay, if there is no exponent, the exponent is 1. Did you hear that over there? What did I say? If there's no exponent, what's the exponent going to be? 1. So I have to draw that. Okay. So this degree is 1. Cool. Let's go ahead and try to graph this. So I'm going to go to graph 182 minus 97x. Kind of weird. What do we press to get the fit? Menu 4A. What kind of graph is that? Straight line, linear. Okay, go ahead and draw yourself a straight line. How many bends does a straight line have? 0. We don't bend at all. Very good. So on the left, the end behavior is going up. On the right, the end behavior is going down. See how that works? Keep doing it, right? Right? Put that away. Now, number 3. Let's graph it. Tab, gonna go up, gonna get rid of this stuff. 3x to the power of 3, go to the right, minus 75x minus 80. I can kind of already see it pretty well, so I'm going to leave it like that. What is my degree? What's the biggest exponent? 3. Does everyone agree 3 is the highest exponent? No? What's the bigger exponent than 3? All right, now let's sketch this. Let's get sketchy real quick. Now, I'm going to put a point every time I see a change in direction. So it goes up, stops, and put a point, goes down, put a point, stops, it goes up, okay? Now, how many bends is that? 2 bends, 2 changes in direction. And on the left, down forever, on the left, and then on the right side, it's going up, okay? Okay, one more if you flip it over. Okay, now, this will be a doozy to graph. When you graph this, please be careful when you type this in. There's many opportunities to type this wrong. So notice there's a negative sign, then 1/5 is control divide, 1 over 5. 1 over 5. X caret 6, go to the right, plus 7 x caret 4, go to the right, minus 45 x squared minus 60. That is a very complicated type, but you should be able to type it all in, right? All right, hit enter, and you see what it looks like. Or a kitty cat. All right, now you could change the window, okay? I'm going to show you another way to change your window, okay? Now, let's look at the paper. Do you see how their little graph goes from -8 to +8? It goes from -8 to +8 on the x, and the y goes from -300 to +300. Okay, here's what I want you to think of. I want you to press menu for 1, okay? So check this out. Oops. Menu for 1 is Windows settings, and you can actually use these numbers, -8 to +8. So I'm going to type -8, +8, and then the y was -300, +300. And you can kind of get a clearer picture of it because you've zeroed in on the window. Okay. Now, I know that's kind of weird looking, but we're going to use that. First of all, what is the degree? What's the highest exponent you see here? Does everyone see 6 is the biggest exponent I see? Okay. Oh my gosh, you're going to miss the most important part. What? All right, so now I want to sketch this. So let's go ahead and sketch this over here. Whoops, horrible. I mean, that's a really bad looking version, but it's something. Okay. Yeah. So I'm going to put a point every time it changes directions. So it starts going up, and then it stops, starts going down, stops, goes up, stops, down, stops, up. Okay. So here's the question. How many bends, how many changes in direction do you see here? Goes up, there's 1, down there's 2, up there's 3, down there's 4, up there's 5. So there are 5 bends, because there's 5 relative maximum or minimums that I can see there. 5 vertices. No. Well, I mean, you can. You're just going to miss the most important part of the notes. Well, I need to get through this whole page. So, all right. So, what's the end behavior on the left here?
Down, down.
Down forever. What about on the right side? Down. Okay. Now we're gonna, as a class, everyone's with me. We're gonna make some observations. Ready? So let's think about this. What's the relationship between the degree and the number of bends? Okay. So let's notice something here. Okay. What do you notice about these numbers of degrees and these numbers of bends? Is there a relationship between this number and this number? What? It's 1 less. Boy, howdy, look at that. 2 minus 1 is 1. 2 minus 1 is 1. 1 minus 1 is 0. 2 minus 2 is 1. And even on example 4, even we had the crazy one, 6 minus 1 is 5. So the degree, the highest exponent, minus 1 is the number of bends you're going to have, okay? So we're going to write that somehow. Let's go ahead and write this down. Okay, the degree equals the bends plus 1. Does that make sense? The degree is 1 more than the bends, so the degree equals the bends plus 1. Another way to say it is the bends equals the degrees minus 1. However you want to write it, it's fine. Okay? Now, second one. How does the degree of a polynomial affect the end behavior? And it says to look at even and odd. Okay? Check it out. Is the first example, is this degree even or odd? Even. What do you notice about the end behavior? They're the same. They're both going down. Okay? All right, what about this one? Even or odd? Even. What do you notice here? They're the same. They're not odd. Okay, so even was the same going down. Even was the same going up. So actually, even doesn't tell you if it's up or down, but it does tell you that so far that they're the same. What about the next one? Odd number? Different. They're not the same. Okay, let's look at example 3. Odd number? Not the same. And then over here, even number? The same. Okay. So here's the deal. When the degrees are even, the end behavior matches on both sides. When the degree is odd, the end behavior is not going to match. Up, down, or down, up, right? So let's go ahead and write that down. I haven't written. I'm thinking of how I'm going to write it. I'm pre-writing in my head. Rough draft. All right. if the degree is even and the end behavior matches, it's the same. If the degree is odd, the end behavior is different. Where you going? We got one more. No! All right, so look at the right end behavior of each function. Okay, now, by the way, underline that. Right end behavior. I don't care about the left. I want to know at the right. Where is it ultimately going to go? On the right, forever. Okay. What about the function determines whether the graph will point up or down on the right hand side? Okay. So let's go back up here. Ready? Can I move this? All right. So I know I did.
There were arrows, right? For the different thing.
Ready? Okay. So we're going to look at the right end behavior. So, ready? Example. What's the right end behavior for the first example? Down. So, what about this equation makes you think it's going to go down in the end? What kind of mindset makes you go down in the end? A negative mindset. When you're so negative, you go down at the end. Okay. Now, what about the next one? The real number one. What's the end behavior on the right? Yeah, up. Okay. So, what do you notice about this that makes it go up at the end? It's positive. It's so positive, it's going to end up going up. Things are looking great. What about this one? Going down on the right. So, now, hold on. Here's the deal. Number 2 is out of order. Okay? Let me show you what I mean. Usually, the highest exponent goes first. So, the highest exponent is 1. What do you notice in front of this 1 right here? Okay? Really, this should have been in this order. And now it's obvious. What's the leading coefficient? Negative, okay? So yeah, negative is down. This one, the end behavior on the right is up because it's positive. Yes. What about this one? The end behavior on the right is negative. Sorry, down because it is negative at the very beginning. And I already said it once, but let me say it again. The phrase for that is called a leading coefficient. So we need to write down one more thing before y'all do anything else. Okay? Let's write this down. Okay. Okay. If the leading coefficient is positive, the end behavior is up. If the end behavior is negative, the end behavior is down. So please remember, the leading coefficient is attached to the degree term, the highest exponent term. Okay, I know that's a lot, but that's as far as we were going to get today anyways, so we did it just in time. Okay, so make sure you keep that, and tomorrow I'll let you know what we move on to.